Okay, what we have to do now is take what we looked at as far as radicals, and now we're going to apply it to a couple different areas today and tomorrow. And both of these are important areas, and I don't think either one is hard. But please, please, please ask questions. So 11.2 is radical equations. Radical equations. And what we mean by that is this part. We mean that the variable is in the radicand. The variable is in the radicand. So now this goes back to our first lesson. Do you remember what the radicand is? Who can raise your hand and tell me what the radicand is? What is the radicand? Emily? It is the thing inside underneath the square root, correct. Or actually the radical sign, because there's more than just a square root. So the radicand is what's inside, and you'll see that in a moment here. Okay, so first off, let's think about a couple things. We gotta learn what are called inverse operations. Inverse operations. So inverse operations undo each other, and that's the key to both today's radical equations and tomorrow's exponential equations, is the aspect of inverse things undo each other. So here's the point. To isolate the variable of an x squared, you don't need to circle that, I'm just trying to focus your attention. What you would do is you take the square root of it. Squaring something and taking the square root are inverses, and guess what? They undo each other. They undo each other. So when we look at this first example, if you were to take the square root of an x squared, the answer is the x. The square root and the squared, the green 2, undo each other. So what's the square root of x squared? It's x. So here's the point. Square roots undo squares. That one we're going to use tomorrow. Square roots undo squares, and we're going to use that tomorrow. Well, here's the second one. To isolate the variable of a square root of x, you want to square it. Bless you. So square roots undo squares, and squares undo square roots. They're inverses of each other. So you can see here on B, I have a square root of x, but I've squared the square root of x. So the green squared undoes the red square root symbol, and the reality is you get to x. So these are two different situations. The top situation, the variable is squared. How do you get to the variable? You take the square root of it. Square root of x squared is x. Second situation, you have a square root of x. How do you get to x? You square it. So the second one is squares undo, and that should be green, squares undo square roots. Because again, when you think about an equation, what are we after? Isolating the variable. What does that mean? Get the variable all by itself on one side of the equal sign. How do we accomplish that? Well, we're either going to have to square both sides if it's a radical equation like we're doing today, or take the square root of both sides like the kind we will do tomorrow. All right, so that's just background. Again, for today, this second one is the key of what we're going to do, but that's only for today. For tomorrow, we'll use the other one. All right, so let's take a look at some examples here. All right, how to solve. All right, I forgot I gave you the little thing just like before. So, how to solve radical equations. Oh, Windows, stop it. How to solve radical equations. All right, step number one is a little bit different. For any equation, we're after isolating the variable. But for a radical equation, your first thought is isolate the radical. Isolate the radical. Then, and it's because we're doing square roots. Later on in Algebra 1 next year, you'll do cube roots and other roots. But for us, we're going to square both sides. So isolate the radical, square both sides, and after you square both sides, you still have more work to do. But listen, after you square both sides, it'll be just like every other equation we've done. Once you square both sides, then you're able to isolate the variable. So first, isolate the radical, square both sides, then isolate the variable. So these are the thoughts that you need to have as you're going through radical equations. You got to think, okay, first I got to isolate the radical. How do you isolate the radical? Same way we've done everything else. Things added to the radical, you move by adding their opposite both sides. Things multiply times the radical, you multiply both sides by the reciprocal. Same deal. Then you'll square both sides. And then how do you finish off isolating the variable? Same way we've done. Things added to the variable, you move by adding their opposites to both sides. Things multiply times the variable, multiply by the reciprocal, or do the shortcut. Same things we've learned, we just now have to do it with radicals. All right, so let's do a couple. First, we'll start out easy, and then we'll make them a little bit more difficult as we go to try to teach you guys the principles. Okay, so I'm going to use my ink here. You don't need to do this, but this is what we're trying to isolate, right? The radical, the square root of n. We're trying to get that all by itself. It's already on the left, so let's leave it on the left. So, class, what would you want to move? A 2, and we already know how to move a 2, right? We're going to add a negative 2 to both sides. So we're moving that 2. So now we have the square root of n on the left, and we have 5 on the right. Does everybody agree with that? So we got the square root of n equals 5. So what's the next step? Somebody tell me what to do next. Kristen, what do we do next? We just did. What do we do next? Somebody tell me what to do next. Chloe? Now we're ready to square both sides. See, the radical is isolated, right? The square root of n is all by itself. Is there anything else with the square root of n on the left? No. We've moved all numbers away from it. It's just the square root of n. We're ready to square both sides. So on the left, because squares undo square roots, Daniel, what will the left be? N. Correct. The squared undoes the square root. And Luke, what's the right? 25. And we're done, right? On this one, once we squared both sides, we also isolated the variable. It's not always that way. We can get a little bit more complicated. This one was that simplistic. Okay? So that's the procedure. That's the idea. Let's do another one. And again, we'll keep trying to get a little bit more complicated as we go. I got to get rid of my shade, so let's just focus on B. So somebody tell me what to do first off on B. Everybody should be thinking, I need somebody to tell me. Everybody should be thinking, I need somebody to tell me. Brendan, what would you do first? But tell me how to do it. What would you do to do that? What are you going to do? Emily, what are you going to do? Won't work. Won't work. What are we going to do? Christina, what do you want to do? Go for it. A couple guys were wrong already. No? Okay. What do we do? Juliana, what do we do? Okay, so we can. So what are you saying for me to do? You in my terms. No, but I mean, okay. Do 3 over 1 times 1 over 3. I mean, what do you want me to do? How? What do you want me to do that? How? Just tell me what to do. Just take it and put it on the other side? I mean, what do you? How are we moving it? That's the question. Now, you said something, Juliana, but I'm trying to get at what you said to figure out if indeed you're understanding here. So, how do you want to move that 3? Okay, and what do you want to times it by? So don't write this yet. Just like that. Okay. Okay, so it would have been good if you would have said to me, multiply both sides by 1/3. Isn't that the way I always talk? Yeah, so that's the way you would want to talk, multiply both sides by 1/3. Or we could do the shortcut, right? So again, you can multiply both sides by 1/3. Oh, Windows, you're driving me crazy. Or we can divide both sides by 3, right? Most students prefer the division when you can do it. On the left, the 3's divide out. We're left with the square root of x on the left, and we're left with 6 on the right. Okay, so what's next? Somebody raise your hand. And again, everybody should be thinking, what is next? Hannah, what's next? Square both sides. And again, squares undo square roots. So class, our left is x, and our right is 36, and that one's done. Okay. All right, so that brings us to C. So somebody tell me what to do first on C. Colby, what do you want to do first? Usually you have an answer before you raise your hand. So next time, have an answer and then raise your hand.
Both sides by -2.
No. No. Brendan? But at least you took a shot. Go ahead.
-5.
Yeah. Look, in this one, don't we have something added to and multiplied times the radical in class? Whenever things are both added to and multiplied, always move things added first, right? So we got to add a -5 to both sides. Now we have a -2 times the square root of y equals a -12. Does everybody agree with that step? Right? We move the thing added first. All right, somebody tell me what to do next. Amber, what do you want to do next? All right, we got to move the thing multiplied times the radical. We can do the shortcut. We'll divide both sides by -2. And now we have the square root of y equals 6. Next step, what are you going to do next? Christina? Square both sides. And class, the left is going to be, and the right is, so we get y equals 36. All right, making sense? So it's a lot of the things we already know how to do. We just got to add in the thought of isolate the radical first, square both sides. So let's keep getting more complex here. That's what we're trying to do, is get a little bit more complex. So now we look at something like D. And this is a more normal type problem. You know what? Yeah, we'll leave it like that's probably good enough. All right, so let's take a look at D. And you look at that, and everybody needs to get in their mind, what are you going to do first? What is your first move? Nia? All right, so Nia sees the radical on the right, and she's going to move the thing added to the radical by adding its opposite, and so she's correct. Let's move that 4 by adding a -4 to both sides. So that leaves an 8 on the left and a 2 times the square root of x minus 1. What's next? What's next? What's next? Raph, what would you do next? So what do you want me to do? Don't. Okay. And so I think Raph's saying we're going to divide both sides by 2. He's doing a shortcut to the shortcut, as long as he remembers to do it on the other side. Okay, so hopefully you all agree right now we're at 4 equals the square root of x minus 1. I want you to finish the problem. All right, I'm going to pause. You guys go ahead and finish the problem. All right, so hopefully you squared both sides. And you got 16 equals. And what'd you get? 16 equals x minus 1, right? Because squares undo square roots, don't they? And now I'm ready to move the 1 by adding its opposite to both sides. It's added to the variable. And we end up with 17 equals x. How many had that? Okay, good. And the rest of you see where you went astray? Do you see the error of your ways? Does it make sense? Right, we squared both sides. Squares undo square roots. So again, that square just wipes out the radical sign. And you always get the radicand, in this case an x minus 1. All right, we're going to add an e to our notes. So I want to do one more before we get to the last concept. Okay, so this one's a little off the wall, but I think you can handle it. I think you can handle it. What if we had 4 times the square root of 2x plus 3 minus the square root of 2x plus 3 minus 5 equals, let's be really creative. All right, let me pause for a second. I got to think this one through to be something nice. Do I want it to be nice? Maybe not. Let's go with -4. Okay, now I want to do a little bit of this one together, and then I'm going to let you finish it. So again, you come across this problem, and here's what you would think, all right? You see this and you say, oh, that's a radical equation. I want to isolate the radical, right? That'd be your first thought. All right, so somebody tell me what to do, the first step in isolating that radical. First step. Nathan?
Plus 5 to both sides.
I would definitely add a positive 5 to both sides, and hopefully you would concur. So now we're at 4 times the square root of 2x plus 3 minus the square root of 2x plus 3 equals 1. And that is the correct first move. Now, what would you do? And I'm going to come to you in a moment, Colby. I want to give people just a minute or two to think. What would you do next? What would you do next? All right, Colby, what are you thinking?
Divide both sides by 4.
It's not a bad idea. Don't do this. Everybody look, though. Everybody look at the screen. This is what would technically happen if you divide both sides by 4. And look, this, you can't do that. That's not true. Because to divide both sides by 4 is the exact same thing. Come on, backward button. What is your problem? Don't tell me it's going to go weird again. All right, here we go. Would be the exact same thing as doing this. And so we're not ready for that step. But it's a thought. And the way you figure things out is you got to try stuff. That one didn't work. Anybody else have an idea? Brendan?
You have to solve the thing under the...
Can't get to it yet. That's locked away in that radicand. We can't get to it. Anybody else have an idea? Luke? Can't do it yet because there's 2 things on the left. We don't have the radical isolated. All right, I'm going to give you an analogy. I want everybody to look up here. If you just had this problem, let's suppose we had this equation. Don't write it, just look. Suppose we have the equation 4n minus n equals 1. What would you do? Aaron, what would you do? And what would you get? Would you agree that's a 3n equals 1, and then we'll go on to finish the equation? Do you agree? 4 of them minus 1 of them, left 3 of them. Does that have anything to do with the problem we're doing right now? Anybody have any idea what the next step is? Chloe? What do you get when you do that? That is correct. All right, first thing I'm going to do is let's stick a 1 here. You guys know it's there, right? Just for clarity's sake, right? A negative is like a -1 of them. Do you agree? Just want to be clear. So we are going to add like terms. There's 4 of them and a -1 of them, and it gives you 3 of them. Now this is tricky, but once you see it, then you're aware of it. So that's really the next step. Now that's only going to work if these are the same. If not, it's a much more difficult problem, and we save those for Algebra 2. Sorry, can't have that much fun yet. You're just not, you can't handle it, all right? You're just not deserving of all that fun yet. So, but we can add like terms. 4 of them minus 1 of them is 3 of them. Does that make sense? It's just like the ends. Okay, so I think most of you would know what to do from here on out, but we better stay together because there's one little twist yet. All right, so somebody tell me what to do next. Amber, what do you want to do next?
Divide both sides by 3.
I would agree. Let's divide the left by 3 and divide the right by 3. See, the difference here, Colby, is there's only one thing on the left. This is all one thing. And before there were 2, and that's what messed us up. Okay, so here's where we're at right now. Square root of 2x plus 3 equals 1/3. Do you agree? So, what's the next step? What's the next step? Daniel? Okay, so I know to do this. How do I square a 1/3? Anybody know how? It's not hard. Brendan?
Use the decimal.
Use what?
The decimal.
Nah, you don't want to use a decimal. Christina?
1/3 times 1/3.
It is 1/3 times 1/3. It's exactly what something squared is. So for you guys, the best way is just use a parentheses and do a squared, which is exactly as Christina said, right? What's a 1/3 squared? A 1/3 times a 1/3. Is it not? Okay, I've really made this thing fun. This is awesome. All right, so do you agree the left is 2x plus 3? Do you agree the right is, well, what do you think the right is? Say it if you know it. 1/9. Awesome. We get to finish with fraction action. Look at Raph, man. He's so excited. He's just pumped, man. All right, so do you agree now we got to isolate the variable? So everybody says add a -3 to both sides. But you know what? I'm going to do it vertical on the left and horizontal on the right. Because how do you add a 1/9 and a -3? You need a common denominator, right? So the left is gone, but on the right, I need a common denominator, so I got to multiply this by 9 on the bottom, right? To get a 9, it's fractions. We got to add fractions. Whatever I do on the bottom, do the same thing on the top. All right, let's see where we're at. 2x equals 1 minus 27 is what? Positive or negative? Negative, right? -26/9. Do you agree? Again, here, I'll do that one off to the side. You have a 1/9 minus a 27/9, right? Equals a 1 minus 27/9, yes? Which is a -26/9, right? It's not a big deal. That's not a hard thing. We can do stuff like that. We've done that. All right, but let's see where we're at now. Now I'm interested to see if you can do the very last itty-bitty step to finish this. I'm going to move to my left here for a little bit of space. So here's where we're at. 2x equals -26/9. Finish it. Finish it. Finish it. And don't be a bum. Hint, hint, hint. Lest you are one. Should be done. This is day 1 of equations. This is back to, well, day 2. Things multiplied times a variable. You move by multiplying by the reciprocal. So what did you multiply both sides by?
2.
1/2, right? 1 over 2. Got to multiply the left by 1/2. I got to multiply the right by 1/2, right? And did you R-bum?
Yes.
Which is like a negative 2 times a 13. The 2's divide out. What do we end up with? A negative 13 ninths. How many got that? Yeah, because look, even though that's as tricky as that thing's ever going to be for you guys at this age. You're never going to get one, if at most one, even anywhere remotely that tricky. And yet it's all things that we really know how to do and we've done. Don't let the fact that it seems complicated scare you or cause you to say, well, I'm not sure what to do. I don't know what to do. Do the things you know to do. Isolate the radical. We know how to do that. Add like terms if you have to. We know how to do that. Square both sides. We can do that. Oh, it's a fraction. Well, that's okay. Square it. Okay? You're squaring both sides, so it's a fraction. Square the fraction. All right, move the thing added. Oh, I got to add with a fraction. Oh, yeah, get a common denominator. Oh, I can't do the shortcut to move the 2 by dividing by 2. Oh, but I can multiply by the reciprocal. And reduce before you multiply. All right, complicated, yes. Doable, though, yes. All right, one last thought. When you're dealing with radical equations, there is one scenario you have to be aware of. If once the radical is isolated, that's the condition. You have the radical isolated. If once the radical is isolated, I'm going to stick the word and in here, and the other side is negative. If once the radical is isolated and the other side is negative, then there will be no real number solution. No real number solution. So I have just 2 examples and we'll finish up today. Example 1. We see it's a radical equation. Our brain says, isolate the radical. We look at it and say, oh, it's already isolated. Cool. So then we say, let's go ahead and square both sides. So go ahead and do this. We square both sides. The left is an n. And what is negative 3 squared? Say it if you know it. What's negative 3 times negative 3?
9.
It is a positive 9, yes? So we get n equals 9. Seems like a perfectly fine answer. Here is the question to that perfectly fine answer. Did y'all catch that? All right, good. Who knows? If I went and took the original, you don't need to write this, just watch. If I took the original equation, it was like that, right? And I put our answer in for the variable. The square root of 9 is 3. Does 3 equal negative 3? And the answer is no. Even though our math led us to that answer is not usable. It's not correct. And the reason is, whenever you take a square root, we talked about this on Thursday, right? Whenever you take a square root, an even root of a negative radicand, you can't get the answer. A negative times a negative is a positive, and a positive times a positive is a positive. So how can you get 2 things times itself to give you a negative? You can't. So, how do you do a problem like this? This is technically what you would do. Now, I know you can't erase, I'm going to, so just watch. So you're coming across this problem. You study your notes and you review, and before a quiz you read number 4 that says, notice, if once the radical is isolated and the other side is negative, then there is no real number solution. And you look at A and you say, oh, the radical is isolated and the opposite is negative, and so you say, no real number solution. And that's your answer. Now you got to say that because you got to demonstrate to me that you know that there's no real number solution. If you just leave nothing there, then all I know that you know is nothing. All right? And nothing's not the answer. It's no real number solution. Now, if you look at a problem like B, it doesn't look like this is the same kind of situation, does it? But here's the thing. Is the radical isolated for B? Not yet. So let's go ahead and isolate the radical. So we'll add a -7 to both sides. So now when I get the square root of x equals -5, I stop. Right? Because now the radical is isolated, the other side is negative, and I say, no, real number solution. Right? No real number solution. Once I get to that point where the radical is isolated, I don't care how complicated the radicand is. The radical is isolated and the other side's negative. I stop at that point. Don't do any more. Don't waste any more time. Just write no real number solution. Now stop. Don't pack up. I just want to one moment here real quickly review the key to everything. So remember, the key to everything is the fact of this. Squaring, taking the square root of a square gets you to x. That'll be tomorrow. Squaring a square root gets you to the radicand, in this case x. That's the key. So how do you do a radical equation? You isolate the radical, you square both sides, and isolate the variable. All right, that's it for the lesson. You guys got about 5 minutes left if you want to get started with homework.